Hello, this is Mr. Dotson-Kelly, an Algebra 2 teacher from East Hartford High School. In this video, I'm going to show you how to fully factor polynomials using both greatest common factor as well as our skills that we learned from factoring quadratic equations. So let's take a look at our first example. The first example is going to be 3x squared plus 6x times x squared plus 3x minus 40. Now this is a polynomial that has already been factored into two factors. So we can multiply this out and expand it to see what the big polynomial is, but we don't want to do that. The prompt here is to factor. And so what we want to do is we want to look at each of these two individual factors and factor them completely. So this is one factor. This is a second factor, and we want to look at these and determine what can we pull out of each of these. So this first one is a binomial, and a binomial is oftentimes more easily factored using the GCF. The GCF, you can find my explanation in another video. We have here 3x squared plus 6x, and we want to find the GCF for this one. So I'm going to really quickly write out 3x squared and 6x in their prime factorization forms. 3x squared is the same as 3 times x times x. 6x is the same as 2 times 3 times x. And I note that in both of these two terms that they both have a 3 in common and they both have an x in common. So rewriting this first factor, I can rewrite that as 3x times x plus 2. So the 3x is the GCF, and I pull that out and I write down what I have remaining. In this situation, I have x remaining for the first term, and for the second term, I have 2 remaining. So that's where I get my 3x times x plus 2. My second term here, though, is a quadratic, and there was a unit we had taught on how to factor quadratics. So as a quick reminder, we ask ourselves this question: what multiplies to the constant, negative 40 in this case, and adds to the linear term, in this case 3. So what multiplies to negative 40 but adds to 3? The easiest way to do this is to rewrite negative 40 as factor pairs. Okay, so I'm going to take negative 40 and I'm going to write out all the different pairs that multiply back to 40. I always like to start off easy with 1 times negative 40. I like to start off with 1, and then I just start counting up from there. So the first term that comes out next is going to be 2 times negative 20. 3 does not multiply to negative 40, so I move on to 4. That's 4 times negative 10. 5 also multiplies to negative 40. That's 5 times negative 8. And that is pretty much all of my basic pairs. I can include into this list the opposites of each of these. So starting with 5 and negative 8, I'm going to rewrite this as negative 5 times 8, and then negative 4 times 10, and negative 2 times 20, and negative 1 times 40. And again, I like to do this so that I can see my opposites. So 1 negative 40, negative 1 positive 40, 2 negative 20, negative 2 20, and etc., all the way in. Now, the nice thing about this is because this is a positive 3, and I know that I need to find a sum, I want a sum that comes to a positive 3, because I'm dealing with opposite terms, I'm going to have to find a term where the larger number is positive. Well, all of these terms are now eliminated. I cannot use these terms. Now I want to find the two terms of what's remaining that adds to positive 3. Negative 5 plus 8 is equal to 3, and that's what I'm looking for. But let's just verify that the other 3 do not add to 3. Negative 4 plus 10 is 6, does not work. Negative 2 plus 20 is 18, does not work. Negative 1 plus 40 is 39, also does not work. So the only pair that works is negative 5 and 8. So my quadratic becomes x minus 5 times x plus 8. And that is my fully factored polynomial. So just to highlight, to show you where I'm getting these numbers, my negative 5 came from here, and last but not least, my 8 came from here, positive 8. So just to rewrite this because it's a little choppy here. So 3x times x plus 2 times x minus 5 times x plus 8. And this right here is my fully factored polynomial. When you are factoring polynomials, you always want to look for two things. Can I find the GCF? Do I have a quadratic? That is what I have here. Our next example has neither of those. And so we have to find a new way to do that. The third way that you need to know how to factor polynomials is called factor by grouping. Factor by grouping. Factor by grouping is a process that utilizes the knowledge of GCF to help us undo the distributive property. So here's the example I'm going to show you. 2y cubed minus 3y squared minus 18y plus 27. And again, my goal is to fully factor this polynomial. But when I look at this, I don't already have a quadratic, and I don't have a GCF for all of these terms. But I can put these into two smaller groups, which then have a greatest common factor. This is going to be my first group, and this is going to be my second group. And so I want to look at these and find the GCF of each of these. GCF and the GCF for each of these. And this one's going to be a special case because we have that negative in front. We want to factor out a negative something as well. So let's take a look at our GCF first here though. What is the GCF of 2y cubed and negative 3y squared? So let's look at their prime factorizations. This is 2 times y times y times y, and negative 3 is negative 1 times 3 times y times y. The only thing they have in common is they have two y's in common. So I'm going to factor out my two y's, y squared, and I'm going to be left with 2y minus 3. And I'm going to go ahead and highlight to show you where I'm getting these numbers from. 2y goes there, and negative 3 goes here with my y squared in front. My second group here is negative 18y and positive 27. Now this is going to be a unique case because I want to factor out a negative 1. So I want to make sure that I have negative 1 times something. So that's negative 1 times 2 times 3 times 3 times y. 2 times 3 is 6, 6 times 3 is 18, 18 times negative 1 is negative 18. To get 27, I'm going to have at least 3 times 3 times 3. But I want to multiply by negative 1 because I want to factor out that negative 1. And you'll see why in a moment. So in order to make this negative 1, I have to make one of these 3's a negative as well. So times negative 3. So negative 1 times negative 3 is positive 3. Positive 3 times 3 is 9. 9 times 3 is 27. So now I have everything multiplies to 27. The reason I did that was I want to factor out this right here. I want that to be part of my GCF. Additionally, I want to factor out these two positive 3's. So now I have negative 1 times 3 is my GCF. So that's negative 9 times whatever I have left over. And conveniently, I have the exact same pair that I had over here. 2y and negative 3. And you'll see now we can utilize our idea of the greatest common factor again a second time to remove this, to factor it one more time. Because again, what do my two terms have in common in terms of their GCF? They both have 2y minus 3 in common. And so I'm going to factor that 2y minus 3 out. 2y minus 3 is getting factored out. And what am I left with? I'm left with the two yellow highlighters. Y squared minus 9. The prompt is to factor completely. And at this point, it might look like you have factored completely, but you always want to double check. If you have a linear factor, such as 2y minus 3, something that looks like a classic straight line, an mx plus b from Algebra 1, that is going to be done. But if you have something with a y squared term in it, it might be factorable even further. This one is indeed further factorable. This is what's called the difference of two perfect squares. Some of you guys remember this from a previous lesson, some of you don't. That's perfectly acceptable. I'm going to really quickly rewrite this over here, and I'm going to include a y term, even though it's not written. There is no y term here. What that means is that the coefficient to y is 0. And we ask ourselves the same question from up above. What multiplies to negative 9 but adds to 0? What multiplies to negative 9 but adds to 0? So let's look at the factors. Negative 1 times 9, positive 1 times negative 9, and last but not least, negative 3 times positive 3. The only way we can add to 0 is by adding opposites. So negative 3 plus 3 is 0. So this gets factored one last time to x minus 3 times x plus 3. This over here is 2y minus 3. And that right there is my final answer. I have negative 3 from there, and I have positive 3 from there. And that, ladies and gentlemen, is fully factoring polynomials. Really quickly, need to correct this. This is not x, it needs to be y minus 3, and y plus 3. Thank you for watching my video. I hope this helps you in your further assignments. Take care and good luck. Bye.